Alright, today's lesson is in Glenco, Chapter 8, Lesson 5, and our focus is on inequalities. So we'll start on page 617 where we'll see the definition of inequality. All right, an inequality is a mathematical sentence that compares quantities. So we'll be using some symbols today that you might not have seen before. And some are review. All right, this symbol means less than. This one means greater than. Bless you. All right, but today we were going to add some extra lines. This symbol with a line will mean less than or equal to. It's almost like it's a half of an equal sign. And this symbol will mean greater than or equal to. So if we put some samples down, we could say 1 is less than 10. We could say that 5 is greater than 3. We could say 8 is less than or equal to 20 because it's either or. Or you could say 7 is less than or equal to 7 because it can be either or. Hannah?
At my old school, we used to do this. The crocodile eats the biggest one.
And that's fine, but today we also have this new line that means or equal to. And then we could say 12 is greater than or equal to 5. And you could say 4 is greater than or equal to 4. So for example 1, you're going to be given 3 choices, and you'll have to decide which of the 3 numbers would be a solution to the inequality. So let's start by working problem A together, and then I'll give you a different practice one to try on your own, because example 1's actually worked out for you in the book. So A gives us 3 numbers, 8, 9, or 10. To solve the inequality, n minus 3 is greater than 6. So I have 3 numbers to choose from. 8, 9, or 10 will be the answer to solve this. So because they give us 3 choices, you could take each one, plug it in, and then compare to see. Alright, but let me show you what to do to find the answer, because every time you won't be given 3 choices. And we're going to work this the same way we were solving equations the other day. Don't let the greater than or less than sign throw you off. We can solve it the same way. The opposite of subtracting 3 would be adding 3. All right, and so then n needs to be greater than, oh, I wrote a 9. 3. Sorry, I guess I did the adding instead of writing what I was supposed to. All right, so 6 plus 3 is 9. So n must be greater than 9. So then I look at my choices. Which of these 3 is greater than 9? Emma?
It would be 10 since 8 is lower than 9.
Well, and 9 is equal to 9. So I don't have my little or equal to sign. So I have to go with 10 as my answer. Now, would 11 solve it as well? Would 12? And I can keep going up to infinity. That's why they're giving you 3 choices so that we can limit it, because there's so many answers that could be right. All right, now I want you to try one on your own. I want you to try well, maybe I don't. Okay, you can do number 1. All right, so number 1 on page 621. One plus f should be less than 7. All right, so you have 3 numbers to choose from.
5, 6, 7.
Everyone should try this on their own. Paige, what did you choose?
I chose 5.
All right, so she chose 5. Let's check. All right, so we have this 1 on the same side as our variable. We need to get rid of this positive 1. So we will subtract 1 from both sides. It leaves f by itself, which needs to be less than 6. Don't be tempted to pick that 6 because you see the 6 here. F needs to be less than 6. So Paige is right. We're going to go with 5. For example 2, we will be given a solution, and we'll have to determine whether yes or no if it's a solution. So let's skip down to example 4. 2 and 3 are worked out for you. So in example 4, we have 17 will be greater than or equal to 11 plus x. Okay, and then they give us the solution. X needs to equal 8. And we're going to determine, is that a correct solution or not? So what we'll do is take this 8 and plug it in for x. So I'm going to write it directly underneath so I don't get confused. Okay, and then I'll say 17 needs to be greater than or equal to, so now I need to add 8 plus 11. All right, so now let's reread what we have. It says 17 is greater than or equal to 19. Is that true? It's not true. So when it's not true, you'll see a line drawn through like that. Not true. And I think in Canvas, it'll have you click yes or no for your answer. Okay? I want you to try B and C. Hannah, do you have a question?
I'm saying that's supposed to be a 7. F less than 6.
Okay, I'll come look at your paper in just 1 second. Okay, so for B, they want A to equal 9. So we plug in 9 for A plus 7. Is that greater than 15? All right, so then we, we add 9 plus 7 to get 16. Is 16 greater than 15? Yes. All right, and then on C, we'll plug in 6 for B. Is 22 less than or equal to 15 plus 6? So if we add 15 plus 6, I get 21. Is 22 less than or equal to 21? No. Any questions? There is a example number 5 with the table. So you've got the same sort of information. It's just given to you in table form. Says Louisa works at a gift shop. She receives a bonus if she makes more than 20 balloon bouquets in a month. Which months did Louisa receive her bonus? Use the inequality B is greater than 20, where B represents the number of balloons she made each month to solve. So when we look at the book, at the table, this one's pretty simple. It doesn't have multiple steps. We just have to know when was the balloons sold greater than 20. So I know you can just look at the numbers and see which ones are greater than 20, but eventually they'll get harder. So they're just showing you the how to check strategy. Just try it out. So you use that formula. So B is greater than 20, and then you plug in the number for each one and go through each time checking. When it's a multi-step equation, it's more than just glancing at it. You'll have to take each one, plug it in, and solve before you know your answer, yes or no. Are there any questions?